We are proud to present you some special quenching tower applications. I would like to underline the concept of tailor-made solutions that you can see in the title, as these solutions have been developed starting from customer needs. In other words, your needs, which might be different. Just to understand where we are, we will see a short video that shows the primary suction line, basically the fumes path at furnace outlet. The video will start just after the furnace fourth hole elbow. Fumes high temperature here more than 1000 degrees, then we enter in the setting chamber for first dust settlement and CO post-combustion, and then quenching tower for a rapid cooling between, let's say, 700 to 220 degrees by means of water injection through some spray lenses. The number of lenses depends on how much heat you need to remove. Before presenting the special applications, just a brief introduction. Here you can see a simplified fume treatment plant diagram. As you can see, we have the electrical furnace, which is the main emission source, and as fume treatment plant, we have the primary suction line for direct suction from the furnace during melting and refining phases, and then we have the secondary suction line by means of the canopy hood that is located just above the furnace for fumes captured during charging and tapping phases. These lines then go joined together to reach the filtration unit. Since the filtration unit works typically at low temperatures, and we saw that the fumes at the furnace outlet are higher than 1000 degrees, we need to cool down, so we need to provide an heat exchanger. For instance, in this scheme, you can see a fumes air cooler that is a natural convection cooler. A good solution, advantages, especially in places where the water has high costs. Another possibility is the quenching tower solution, today's topic. The heat exchange mechanism here is by means of evaporation. We will not go through all plus and minus of this solution, but for sure we can say that this is an effective solution for dioxins abatement, thanks to the rapid cooling inside the de novo synthesis temperature range. But let's see this first special application that we call refractory-free quenching tower. Here we are this is a greenfield plant in the United States, and the fume treatment plant is serving a 177-ton stamped steel. Here the customer target was to obtain low pressure drop, that means low energy consumption, and low maintenance activities. So, starting from this concept and from this request, we designed and developed this special solution that is a stainless steel quenching tower without refractory. As you can see in the picture, the upper part is in stainless steel, the lower part in water-cooled panels. So the first advantage of this solution is in terms of low capital costs, simply because you do not need to install all the refractory linings. To make an example, for a furnace of 150-ton tapped steel, we can have an average saving of 100,000 euros. The second advantage is in terms of maintenance, because with this solution you avoid wrecking and rebuilding all the tower shell. That is a quite demanding job. So at the end, a smart solution both in terms of capital and operative costs. Let's see the second special solution that we call integrated quenching tower. I feel very close to this project because I feel I made the on-field measurements years ago and the most recent plant tuning activities. Here, this is a brownfield plant in Asia, and the fume treatment plant is serving a 68-ton tapped steel. Here, the customer need, so again, this fundamental concept that comes back, was to minimize on-field interventions. Well, that was a challenging request considering the limited spaces. So we developed this solution. We put the spray lenses directly inside the setting chamber, as you can see on the picture. In this other picture, you can see the lateral view. You can see the primary suction line. You can see the position of the spray lenses in the in the plant. And as you can see, the solution is very compact. All the equipment is under the working platform. Moreover, with this solution, we avoid to change the position of the connection between primary and secondary suction line. That was highly appreciated by the customer. Marco, do you want to tell us something about the other applications?
Yes, certainly, Massimo. Yes, I would like to introduce you a third one after the two that Massimo have clearly explained you. If you remember, in the first one, he said the one with the stainless steel, we try to evaporate the refractory in the body of the cylindrical part. In the second one, we try to eliminate the cylindrical part. In this third application, we just simply keep the evaporation of the water, but we have eliminated the compressed air. The plant was, as you see in this picture here, located in Canada. It was located in a new installation of a new electrical furnace that was, let's say, boosted up from the original production. It was served by two baghouses that was still remaining in place. We have only done the primary line as new one. So before there was inside a smaller quenching tower and a smaller water cooling duct. The problem here was to deal with the temperature, to have proper temperatures. If you see on the next slide here, you will see what we have done. We have prolonged the horizontal duct, we have prolonged the water cooling duct with the same water as before. So same pumps, same flow rate, just increasing the delta T because we have optimized with our classical solution of the water cooling ducts put to the water in series. So after this water cooling duct, the water was entering the quenching tower, that is the vertical portion that you see back on my shoulders. And there we have placed some special lenses. So if on the Saturdays like me, you are sometimes washing your car, the lenses, the spray water lenses are similar to the one that you are washing your car, the lenses that you wash your car with. We call it hydropolytration. So these kind of lenses are giant and have a particular feature. So we have some hair on the sides because the water runs so much. When you're using high pressure water lenses, instead of 6 bars, 30 or 40 bars, the water runs double. So the evaporation takes longer time and you need to shorten this path in order to not make a very, very tall quenching tower. So we have put on the sides some air, not compressed air, with a small fan in order to keep this, with this air very near the water and evaporate it sooner. The task was, it was not a novelty, but the task was to try to keep the two baghouses with just, I can tell you the number, if you see the size of the furnace, 125 tons, the two baghouses was only having a size of 1,020,000 cubic meters, 600 ACFM American, so very, very short. And we reached that one, both in summer times and also in winter times, because this plant is working at minus 30 degrees, being outside in Canada. So now let's go on the next picture. Let's make a comparison in between the two systems. On the two photographs on the left-hand side, you will see the typical centrifugal pumps and the compressors that are the standard 6 bars and 6 bars. And you have the comparison with the one on the right-hand side that is the multi-stage pumps and the low-pressure blower that I was mentioning before. So by adopting this, you have to balance in between the capex. If you make some small profit and loss, you will see that the capex is very similar, but the OPEX are better. Why so? Because when you are blowing the air with a small fan, the specific consumption will decrease approximately by 2.5 kilowatts per each cubic meter of the pumps you have installed. So if you go on the next slide, this is the number that you can reach. So you can have a saving by eliminating the standard solution of about 40,000 euros per year with a ratio of plant economic 7,200 hours in a furnace of 150 tons and with a 0.05 euro per kilowatt hour. This is a benefit. A benefit that it's good, but in this particular case, it was not so good because at the beginning, the multi-stage pumps, this is the problem, it's a probe, not only the cons. It's a cons, not only a probe, sorry for that. It was some problems with the dirty particles that they spoiled the impellers, and was the need to go back to the warehouse to remachine the impellers a couple of times during the startup. So in general, if you don't have very skilled workers or a good team in order to manage the upstream equipment, please, this you have to take careful in consideration if you want to have the benefit of these capex that we are showing you. This solution, in any case, can be applied, one of the three, can be applied also as a further part of the spoiler that told you before Alberto when he was talking with Manolo. If you have a heat recovery system, you can use this kind of quenching towers also as a bypass. Why so? Similar to the one that we talk about, the coarse particles in the water, also the coarse particles in the air or in the fumes can time by time spoil the water cooler ducts. Everybody of you probably is familiar with this fact. This typically does not happen so much with the cooler ducts, but it happens a bit more, especially if you have dirty scrap and so on, with the heat recovery boilers can be evaporative or also pressurized water. So in this case, if you have your team that is not able to act very, very fast, one idea, an option idea could be to install this quenching tower as a bypass line. So, to avoid the stoppages as is shown there in this paper. In the three solutions that we've shown you before, the one that we prefer is the first one that I've shown Massimo, that is the one with the stainless steel that you can have also a smaller capex at the beginning, and also along the time you will not have any kind of problem with the refractory anymore in your life. So I think that with this we have concluded this paper. We will be very happy to have some questions from you. What we have described, also all this data we have going around, are already described in the tech book that we have. You can go with QR code, and was also included in the ISTEC proceedings in Columbus 3 weeks ago that we presented Massimo and we this paper. Thank you for your attention.
Okay. Question and answer. Please, first question.
Okay. As you explained, that the quenching tower without refractory, being internal server with lower temperature, little fishes or more build up due to sticky particle. Yeah, the one that we was talking now. Question very simple. No. No, but it's not just no. I can give you an example. Yeah. The plant that you see there, it is located in the United States. The one there, we have a fact. Massimo and Caterina, two of our engineers, was willing to go down about 2 years ago, April or May 2022, just a few months after the startup. The customer was saying that was having some water from the hopper of the cyclone, some water exiting from there. And he said that the water probably was due to the fact that it was entering from the safety valve. The safety valve was on the side with the rain, 45 degrees rain entering in the safety valve. We said, no, it's not possible. But we was very lucky because nearby there was an airport. We get all the data of all the rainings, all the dew points and so on. And we easily calculated it was not possible. And we asked the customer, probably you have a common problem in the quenching towers. That is maybe some sticky particles on the thermocouples. That gives you a delay on where you have to blow in the water inside the quenching tower. And then it means that you can have conditions of dew points. We've gone into, personally with our people, we take it out and we recover the problem. This is what to say. We had a problem of sticky things in the cyclone very far away from the quenching tower. But the quenching tower was not obstructed by dust. So if the question is, in this case that you have the walls that are colder, nothing happened. And we was very lucky that on the filter we didn't have any kind of problem with the dew point because the filter was a bit warmer than the cyclone that was before the filter.
Okay. Second question, please. The elimination of the cylindrical body presented in the Asia application, can it be used also to jumbo furnaces?
I don't want to say yes and no, but probably no. It is not economically good because you've seen the one that we showed before was just a 68 furnace. Jumbo furnace is 300 furnace. I don't want to say that it's 5 times longer because you have economy, but you know, if you have the surface on the sides, the peripheric surface, they're not increased so much. So at the end, you will have, and it is not economically feasible, a 40-50 meters long length of this chamber here is something that it cannot be done. So average size of furnace, yes. Bigger, no.
Okay. Thank you.
Thank you.